Okay, we're doing lesson 23, the volume of a right prism today. At the top, I've posted two different formulas. It's the same formula, just written two different ways. To find the volume of any object, you have to find the area of the base and then times it by the height. So that's exactly what this one is here. To the right, also volume is V equals base times height. Area of the base times the height. And that's any shape. Our definition for volume would be like how many square cubes can fit inside that 3D shape. So like if you got an Amazon box in the mail, it'd be how many cubes could fit inside that box. Or your cup that you're drinking from, what would be the volume of that? How many cubes can fit inside that cup? So looking at our opening exercise, it says the volume of a solid is a quantity given by the number of unit cubes needed to fill that solid. Most solids, rocks, baseballs, people, cannot be filled with unit cubes or assembled from cubes, yet such solids still have a volume. Fortunately, we do not need to assemble solids from unit cubes in order to calculate their volume. One of the first interesting examples of a solid that cannot be assembled from cubes, but whose volume can still be calculated from a formula is a right triangular prism. What is the area of the square pictured to the right? Explain. Well, we know that the area of a square would be length times width. So if I can figure this out, I have 1, 2, 3, 4, 5, 6. It's a 6 by 3, 6 by 6. So the area of this is 6 times 6, which is 36 units squared. And I could count each individual square, 1, 2, 3, 4, 5, 6, and so on, because that's how many squares are in that, but it's easier to use this formula, length times width. Draw the diagonal joining the 2 points, then darken the grid within the lower triangular region. What is the area of that triangular region? So let me see if I can insert a line here. We need to draw a diagonal from one point to the other, and then it says to darken the grid lines in that lower portion. So that'd be like, that's kind of sloppy, but shade in this area. And they want us to find the area of this region. Well, area of a triangle is base times height divided by 2, or base times height times 1/2. Same thing for a triangle. Either one of those work. So I already know my base is 6. Height was, again, 6 because it was a square, divided by 2. So this would be 36 divided by 2, which on my calculator, 36 divided by 2 is 18. And it'd be units squared. Exploratory challenge, the volume of a right triangular prism. So far we only had this 2D shape. Now we're going to prisms, these 3D shapes. What is the volume of the right prism pictured on the right? So remember, it's area of the base times our height. But we already found, I know that this is again the 6 by 6. And so I know the area of the base is 36. And then my height is from here to here, which I can see that's only 1 cube, so it's 1 unit thick. So I have to times that by 1, which just gives me 36 units squared. Volume is the area of the base times the height. Okay. draw the same diagonal on the square base as done above, then darken the grid lines on the lower right triangular prism. What is the volume of that right triangular prism? Explain. Okay, so again, they want me to draw that diagonal across, and I'm just going to use this instead of redrawing. So that would be here, and then they're wanting the volume of this piece, this side. Well, volume is area of the base, or B, times our height. If you remember from before, the area for the triangle would be 6 times 6, base times height, divided by 2, which was 18. So this was 36 divided by 2. And then I have to times that by my height, which we already figured out was 1 unit. So the volume of this triangular prism is 18 units. Oh, cubed, and you know what? I said squared. This should also be cubed. Volume is cubed. Okay. How could we create a right triangular prism with 5 times the volume of the right triangular prism pictured at the right? So this guy is just 1 unit high, and we want to find a right triangular prism that is 5 times that. And we don't want to change the shape of this base. We still want it to be look like this, the same triangle. Okay. Draw your solution on the diagram, give the volume of the solid, and explain why your solution has 5 times the volume of the triangular prism. Okay, so I've redrawn this right triangular prism with a volume that is 5 times. So this, so this was our original side, and then I just did the same exact shape, but with 4 more layers, because then I'd have 5. 1, 2, 3, 4, 5. Give the volume of the solid. So I already know that the base was 18 units squared, and I have to times that by its height, which is now, I know, 1, 2, 3, 4, 5 units. So if I do 18 times 5, that would be 90. So 90, and if I do unit squared times units, that would be units cubed. So this shape, triangular prism, has the volume of 90 units cubed. What could we do to cut the volume of the right triangular prism on the right in half without changing the base? So again, I still have that same base, but if I want to cut the volume in half, I would just have to cut the base in half, this shape. So that's not a perfect example, but you get, I'm trying to slice this in half. Draw your solution of the diagram, give the volume of the solid. So I already knew the volume of this was 18 units cubed. And if I wanted to cut it in half, I could either times by 1/2, or I could do 18 divided by 2. And 18 divided by 2 is 9. Still volume, so it's going to be units cubed. Okay, to find the V volume of any right prism, we have to do, so this is going to be a formula you're going to want to write down on your note card. Volume would be area of the base, the base times the height. And if you would prefer to write that, volume equals base times height, that's fine too. Or you can just do V equals BH, because if you get rid of that, you know B and H would be multiplied. So knowing our formula, volume equals area of the base times height. Let's look at our next problem. It says find the volume of the right triangular prism shown in the diagram using this formula. So my base is this triangle here, and it looks like to find the area of a triangle, I have to do base times height divided by 2. And I know my base is 4, and my height is 1/2. So 4 times 1/2, and then I have to divide that by 2. So 4 times 1 is 4. 2 times 1 is 2. 4 divided by 2 is 2. And then I have to divide that by 2. So 2 divided by 2 is 1 meter squared. That's the area of the base. Now I have to times that by my height, which is this piece, which is 6.5 or 6.5. And anything times 1 is always going to be itself. And I should say meters. So 6.5 times 1 is 6.5 or 6.5 meters, and the volume is always cubed. So that would be the volume of this triangular prism. Remember, area of the base, which is this piece, times the height. Multiple volume representations. The right triangular prism is composed of a right triangular prism, rectangular prism, which is this box on the bottom, and a right triangular prism, which is this guy, the top piece. So it would be like when we did those composite shapes, splitting this into 2 different shapes right here. We've got the triangular part, the top half of the house, and then this box on the bottom. Find the volume of the right pentagonal prism shown in the diagram using 2 different strategies. So again, volume is area of base times the height. Here I can see this triangular prism is the same as the one that was above. It is 4 by 1/2 by 6.5. So I know that that volume is 6.5 meters cubed. So this is the, and I'm just going to do the volume of the triangle, 6.5 meters, whoops, cubed. I don't know why I keep doing squared. And then I have to do the area or the volume of the bottom cube. So the area of this base would be 4 by 6.5. So I'd have to do 4 times 6.5. That's the area of the base times, and my height is also 6.5 times 6.5. So area of the base times the height. Area of the base times the height. Okay, so let's do this on our calculator. I need to do 4 times 6.5 or 6.5 times 6.5 equals 169. So the area of this cube is what, 169.0 meters cubed. And then I can add those. So label is meters cubed. if I have to add the volume of this triangle piece and the volume of this square piece. So this would be 5 plus 0 is 5, decimal. 6 and 9 makes 15. And 6 and 1 is 7, 1. So one way is to find the volume of both pieces. So the volume of the whole thing is 175.5, or you could say 175.5 meters cubed. Okay, that's the first way. Another way that you can do this is to find the area of both of these flat pieces. So this triangle flat, the base, which was 4 times the 1/2 divided by 2, which again we said earlier was 1 unit. And then this, which was 4 by 6.5. So let me try that. 4 times 6.5 is 26. So 26. And add the areas. So 26 plus 1 is 27 units squared. That would be the area of the flat piece, this whole front side now, because you've added together the triangle plus the square, and then times that 27 by the height, which would be 27 times 6.5. Should give us the same answer. So 27 times 6.5 equals 175.5, which is exactly what we got before. So again, the volume would be 175.5 units cubed. So either way, if you want to find the volume of each individual piece and add them together, or find the area of both of these pieces, add them, and then times it by the height, there's 2 different ways you can do that when you have a composite shape with 2 different shapes on it. Okay. We will go over our exit ticket and in class, and then I'll give you your problem set questions today.